All right. Thank you all for joining. Sure appreciate you all joining us for this holiday special event. Thanksgiving is just around the corner, and we typically meet towards the end of the month, but with a holiday, we figured we'd move up the date a bit and get someone in special to share with us their thoughts. So we're really excited to have Jez Humble with us today. He is an 18F alumni, so we're really excited about him being back to share with us on his thoughts about DevOps. Just a reminder that this meeting is being recorded, which is great. You'll be able to share the content later with colleagues in the near future to help spread the word of DevOps and what's possible. And just some reminders about what we're about. This is about spreading best practices and the courage to change related to DevOps, Agile, cloud adoption across government. It's for the technical and management lessons, including the successes and things you all learned. Going forward, this particular event, this special event, is going to be a little bit longer than normal. We're giving Jez 45 minutes today to share with us. We'll have time afterward for a little bit of a Q&A. If you have any questions, put them in the chat, and I will be emceeing at the end and presenting those questions to Jez. We'll try to get through as many questions as possible. Please be patient with us, but use that text feature or chat feature to pitch the questions this way. And there is going to be an opportunity for discussion beyond the event in our listserv, so please use that. And again, just a reminder, the video will be posted after the event. Please share at your leisure, as we think the video content helps spread the knowledge beyond the folks that were able to have the time available to attend today. Otherwise, from a logistics standpoint, Alex, anything else to share?
Brian, you're a pro. You covered it all. As a reminder, you guys won't be able to unmute yourselves, so put all of your questions in the chat. And this event is being recorded and will be posted on our event page. Brian, I will kick it back over to you.
All right, and Jez, right over to you. Thank you so much for being here today, and we're looking forward to what you have to share with us.
Great, thank you so much for having me. It's a pleasure to be back, albeit temporarily, talking about DevOps in the context of government. I'll try and keep it to 40 minutes, so there'll be plenty of time for Q&A at the end, and also because I'm sure many of you have a short attention span like I do. So today I'm going to be talking about a research program that I've been working on for the last 6 years, looking at what makes high-performing organizations, how do you measure performance, the things that impact or predict high performance, and giving people a chance to ask questions about it. So first of all, the kind of research we do, this is an academically rigorous research program. I work with Dr. Nicole Forsgren, who's the principal researcher on this program. She has a strong background. She was a tenure-track professor at Utah State, and she designed and executes this research program. What we're looking at, or the kind of methodology we use, gives us something called predictive analysis, which means that we can show that certain things predict other things or impact them. In order to be able to do this, you've got to use one of 3 different methods. You can use randomized controlled experiments, which we don't do. It's very hard in software to do randomized controlled experiments because we're operating in complex systems, and because it's quite difficult to have a control group team building something and then a treated team building something to do randomized controlled experiments, which is why there's so little kind of good science on how to build high-performing teams and how to do software delivery. We are not doing longitudinal research where you follow a team over time or a group of people over time. Again, that's quite expensive and difficult to do. What we do is called theory-based design, where we take theories that have been already validated in the literature and use those to develop hypotheses, which we then test using surveys. So Where we haven't used theory designs, we only talk about correlations. Where we have used theory-based design, we talk about impact and prediction. You've got to be a bit careful about correlations. This is from Tyler Vigland's website, which I highly recommend, where he has a number of graphs talking about correlations between things. This is one of my personal favorites, which shows that per capita cheese consumption is correlated with the number of people who died by becoming tangled in their bed sheets. So it's possible to have very high correlations between things that are probably not related. And sometimes when you see correlations, it may be because you don't know which direction causation is operating in, if at all, between those things, or whether in fact there's a hidden variable which is actually impacting both of those things. So you've got to be careful about correlation, although that's not to say it can't be useful, but it's very easy to go trolling through the data, looking for correlations, and then coming back and saying, hey, I found this amazing correlation. Well, that doesn't necessarily mean anything. What we want to do is use theories, develop hypotheses, and test those hypotheses. And never, I mean, just in general, one should never go trolling through data sets without a theory and a set of predictions that you're testing first. And indeed, we don't do that. We're very careful about that, tempting though it is. So first of all, probably the most important result is that we show that your ability to deliver software is actually important. We've been told for years that software delivery is kind of a utility. It's not going to give you a long-lasting competitive advantage. We found in 2014 that firms with high-performing IT organizations were twice as likely to exceed their profitability, market share, and productivity goals. So software development matters. Obviously, we're all working in the public sector. Turns out it's important there as well. 2018, 2019, we've validated this result for several years now. High performers at software delivery were more than twice as likely to achieve or exceed the following objectives: quantity of products or services, operating efficiency, customer satisfaction, quality of products or services provided, the ability to achieve organization and mission goals, and measures that demonstrate to external parties whether or not you're achieving your intended results. So in public sector, software delivery capability matters as well. Now, the question that you should be asking at this point is, what's a high performer? What does it mean to have high performance? So we actually found 5 measures that are important. One of those, availability, only really applies when you're building hosted services. The other 4 on this screen apply for any software development capability, and those are the 4 that I'm going to focus on in particular. 2 measures that focus on how rapidly you can get stuff done. One is lead time, which is the time that it takes from making changes in version control to having software released to users. Deployment frequency is how frequently you do that deployment or release to users. And then in blue, 2 measures of stability. One is change fail rate, the percentage of changes that require some kind of remediation, which is kind of a measure of the quality of your release process, if you like. And then time to restore, which is when there is some kind of incident, how long does it take you to remediate that incident? So if you only take one thing away from this hour, it should be this: high performers do better at both speed and stability. They are not making trade-offs. When you hear this kind of Silicon Valley thing, move fast and break things, that's actually a fallacy. And for the last 6 years we've been doing this research, we found this consistently. When we've analyzed the data, we do something called cluster analysis. And if you're not familiar with statistics, that's a bit like the Harry Potter sorting hat, where we take all the data and tell the algorithm to sort it into buckets. We don't know what those buckets will look like. Every year it's split into 3 or 4 buckets. And we found there's an elite bucket where people are doing really well at both speed and stability, and then a low performing bucket where people do really badly at speed and stability, and then 1 or 2 buckets in between. So it's consistently been the case that we find that high performers do better at both. High performers are not trading off speed against stability. They're doing better at speed and stability. And the various things that help you get better, if you do it right, help you get better at going fast and at building more stable, reliable, available services. And this is not something that's just true in software development. This is what happened in manufacturing as well. The lean revolution, Toyota, Honda, all these companies in Japan, they didn't destroy the US auto manufacturing market by building poor quality cars faster and cheaper. They built higher quality cars faster and cheaper, and basically changed the game. They transformed how manufacturing works through things like just in time. And you can think of a lot of this stuff as the application of those principles to software delivery, and they make it faster and higher quality and more stable and cheaper. So what we're doing with these practices that I'm talking about today is fundamentally changing the game, not making trade-offs between things. We have a huge amount of data, more than 30,000 data points by now across the last 6 years. It's the biggest rigorous academic research project looking at DevOps and software delivery practices. And it's across all different sizes of organizations. So 25% of our respondents are in organizations of 10,000 people or more. And it's across all different domains. We have 5% of respondents come from government, and we have lots of respondents from other highly regulated domains, such as healthcare and pharmaceuticals and financial services. In fact, 14% of our respondents come from financial services. So these results apply in big companies. These results apply in highly regulated companies. You will find high performers in large, highly regulated companies, or high-performing teams, I should say, in large, highly regulated companies. You will find low-performing teams in small startups. And I certainly, let's say, have a friend who's worked at startups which, are low performers. So it's very common in government, and I know because I worked in government, to think, well, this is government, it's not the private sector, we can't do this stuff. That's not the case, and the data shows that that's not the case. You can be a high performer in government, and I certainly, I'm going to end this webinar with an example of a team that I worked in government, the cloud.gov team, where we were able to apply all of these tools and techniques. So you can do it in government. It's absolutely possible. It's hard. It's hard everywhere. But what I'm trying to do here is inspire you that, not to lose hope and think you can't do this, because you can. So if you are not a high performer and you want to be one, your question is going to be, how do I get better? And that's the question we asked. We have found over 25 capabilities, and it grows slightly each year. This is actually from the consolidated, what we lovingly call the BFD, or the big and fulsome diagram, which describes our research program. We found over 25 capabilities which predict software delivery performance. So you can see that kind of box in the middle on the right, SDO performance, that's software delivery and operational performance. That's those 4 metrics of software delivery performance plus availability. We know that predicts organizational performance, commercial and non-commercial. And then there's a whole bunch of arrows pointing to it. And an arrow here means that something predicts or impacts the thing that it's pointing to. So that's more than correlation. It's inferential prediction. We've inferred that the things on the left-hand side of the arrow predict the things on the right-hand side of the arrow. So if you want to get better at SDO performance, there's basically 4 clusters of things, which I'll go to in a bit more detail over the course of the webinar. One is a bunch of lean product development practices. One is a bunch of lean management practices. Then there's a whole set of technical practices that together make up continuous delivery. And then up at the top, there's a whole bunch of kind of cultural things that are important as well. And culture is measurable. I'll talk about it later. And there's things that will change your culture. Implementing things like lean management and product development practices impact culture. Implementing these technical practices impact culture. And they also impact your teams in other ways. They reduce burnout. So a lot of these practices reduce team burnout. They reduce deployment pain. Continuous delivery in particular reduces rework, which is an interesting proxy variable for quality. It's hard to measure quality because quality is subjective. But what we did do is we measured rework, which is when you do something, what amount of your time is spent fixing things that you didn't do right the first time. And so we show that if you implement continuous delivery, you spend less time doing rework, which basically is a way of thinking about improving quality. All these things are supported by effective leadership. So how do you implement the capabilities? Well, that requires effective leadership, which is the transformational leadership box on the left. So I think the interesting thing about this diagram is basically the way that it's set up, which is, again, theory-based. Organizational performance is impacted by software delivery performance. How do you improve software delivery performance? You implement all these practices, which impact culture. Culture impacts software delivery performance. A lot of these practices directly impact software delivery performance. How do you implement these practices? Well, you need leadership support in order to give you the resources and time and support in order to do that. That's kind of basically the TLDR from this diagram. This is particularly important in the context of government. Dave Zveniach, who was acting executive director of 18F at one point, wrote a nice blog post about how you can use this in the context of acquisition. So there's a framework for looking at performance-based acquisition. And in this blog post, he talks about how you can use this framework to assess vendors and measure the performance of vendors as part of a performance-based acquisition program. So this is kind of an interesting. Accelerate is the book that we wrote based on the research, and then there's been 2 more years of research after we've written the book as well. But I thought that was interesting to think of how you could use the framework as part of acquisition as well. So 4 things I want to go into in a little bit more detail. Number 1, continuous delivery. Number 2, lean products management and management practices in general. I want to talk about culture and psychological safety, and finally, autonomous teams. And as I say here, you know, a lot of the time in the industry, we focus on individuals. Individuals don't deliver results. Teams deliver results. And I think in general, we're much better off focusing on how to build high-performing teams than necessarily worrying about individuals. So diving into continuous delivery, here's my definition. Continuous delivery is about making releases boring. It's about getting all kinds of changes, whether those are config changes, bug fixes, experiments, features, whatever, into production or in the hands of users safely and quickly and sustainably. And really the litmus test is, can we push out changes to production during normal business hours at the push of a button without incurring downtime? If you have people working evenings and weekends to do releases, you're not doing continuous delivery. And really the whole reason we wrote the book back in 2010 is because we were sick of people having to work evenings and weekends. Now, obviously, you can't do that in government anyway, but definitely being able to make releases a boring, predictable process that can be done on demand at any time. That's really the goal. And it's fundamentally a set of technical practices that enable this. Things like trunk-based development instead of working on feature branches, continuous integration, automating testing and deployment, using version control for everything, including infrastructure and database changes, continuous testing throughout the software delivery lifecycle rather than having testing as a separate downstream phase after development complete, having good monitoring and then actually acting on that monitoring, and architecture, which I'm going to talk about in a bit more detail shortly. And as I say, those practices altogether, they impact software delivery performance. They make it easier to deliver fast and reliably. They also improve your culture, and they result in less burnout on teams, less deployment pain, and less rework. And fundamentally, they're focused on building quality in. This is W. Edwards Deming, an American statistician who helped the Japanese industry rebuild after the Second World War, one of the key figures in the lean movement. He says, cease dependence on mass inspection to achieve quality, improve the process and build quality into the product in the first place. And really what this is about is, instead of this kind of traditional phase gate process where we have a development phase and then a testing phase, and then we go and do you know, NIST risk management framework after it's all dev complete, let's be doing all that stuff throughout the software delivery lifecycle, and delivering incrementally and iteratively, and building that stuff in. And you know, this is particularly important for the ilities, things like performance and security and scalability. You can't take software that hasn't been designed in a way where it, you know, actually performs reliably in production and is secure, and then try and fix that stuff later. You can't wave the magic DevOps wand and then have the DevOps fairies come and somehow inculcate security and performance into software that wasn't designed with that in mind. You know, the obvious example of that is healthcare.gov, where you had all these different vendors, and none of them cared about the security of the the performance of the system fully integrated operating in production. That wasn't anyone's responsibility, and it was incredibly hard to solve that problem. So we don't build bad software because we're dumb or because we're evil. We build it because we don't have the feedback loops that we need to find out whether what we're doing is actually going to work in production with production data sets and production loads, and if it's going to be secure in those environments. And so a lot of this stuff is about giving development teams the tools to be able to create those feedback loops so that they can build quality in, because it's so expensive and painful to fix those problems later if you don't build that stuff into the development process. This is true of security as well. We did some research on security a couple of years ago. We found that when teams build security into the software as part of the development process, that improves both performance and security quality. Teams that do well conduct security reviews and complete changes as a result of those reviews in the process of days, because again, they're building security in. They can conduct security reviews and complete changes. If you're in the low performing group, that takes weeks to conduct security reviews and complete changes. Elite performers can do it in days. And elite teams build security in. They run security tests as part of the development process, as part of their deployment pipeline. And InfoSec has a really important role, but that role is not to individually check every bit of software or every change. It's to enable teams to build security in by giving them pre-approved libraries that are validated that they can use, giving them tool chains and processes that they can use to build security in, rather than InfoSec being responsible for security and then starting their work after development complete, which is not how you build security in. So building security in improves security, it improves performance. InfoSec has a really important role enabling development teams to build security in. I want to talk a bit about architecture. Architecture was the biggest factor in the ability to achieve continuous delivery the years that we've researched this. And people think about architecture, they think about microservices, Kubernetes, and actually we found that what's important is not the particular technologies people are using or the patterns, but the outcomes. And in particular, whether teams could answer yes to these 5 questions. Can my team make large-scale changes to the design of its system without the permission of someone outside the team or depending on other teams? Can my team complete its work without needing fine-grained communication and coordination with people outside the team? Can my team deploy and release its product or service on demand, independently of other services the product or service depends upon? Can my team do most of its testing on demand without requiring a complex integrated test environment? And finally, can my team perform deployments during normal business hours with negligible downtime, which is the continuous delivery bit? And if you can answer yes to these questions, that's a strong predictor of continuous delivery and your ability to achieve that. Now, you can do this stuff with mainframes. And on my site, continuousdelivery.com, there's a section on evidence and case studies. There's a case study from Suncorp, which is Australia's biggest insurance company, talking about how they did continuous delivery with mainframe systems. Equally, you could build a whizzy new architecture with Kubernetes and microservices and not achieve these outcomes, in which case it was a massive waste of money. So I think a key part of governance around software delivery is and governance around architecture and architecture in general is about these outcomes. How can we actually make sure teams are achieving these outcomes? Are we even looking at this, and how can we enable it? That's really important. I want to switch gears a bit and look at lean management and product development practices. What we find is that these product development and management practices are important. The management practices are kind of interesting. One is limiting work in process, and that means, it's a common fallacy of management that's kind of well known, but still insufficiently observed. That if things are going badly, we'll just let's add more people and push more work into the system. Let's work on multiple things at once so we can get them all done. That's a terrible idea. You should reduce the number of things you're working on so that you can get the things you're working on done as fast as possible. Because again, we want to focus on lead time, on getting things done quickly, rather than how many things can we do. Well, the only way to get things done quickly is by actually getting them done. So reducing work in process is a way to reduce lead time. What we found, which was fascinating, is that limiting work in process on its own doesn't impact software delivery performance. You have to combine it with these other things. Visual management, which means having displays that show you the state of the software delivery process. Things like, is the build failing? Are the tests failing? How many tests are failing? So visual displays that tell you about the quality of the software you're building. Actually getting and acting on feedback from production. And then finally, a lightweight change approval process. And this is something we did a redux on this year. What we find is that having an external change approval process, where there's someone else doing change approvals, it reduces throughput substantially, as you would expect, but it does nothing to improve stability and reliability. The best way to do change approval processes is to have other people in the development team review the code and mark it as done. And that's a perfectly valid way to meet the goal of segregation of duties, which obviously is an important control in NIST 853. But you can achieve that goal by having other people within the team review your changes and mark them as having been reviewed, either using GitHub pull requests or by pair programming. Frankly, that's a perfectly valid way to do it as well. So lightweight change approvals means that change approvals happen within the team rather than outside the team, and that substantially increases speed without any negative impact, or with negligible negative impact on reliability. In terms of product development, it's all the things that you might expect, but it's great to see them validated with data, working in small batches, which means being able to get features delivered in a few days. So make your features small enough that you can deliver them in a few days. Make the flow of work visible by using tools like Kanban boards or value stream mapping, or other tools that make it clear to everyone on the team how work is flowing through the system, gathering and then implementing customer and user feedback. And then finally, team experimentation, which means that teams should have the ability to experiment with feature ideas. A lot of teams are adopting Agile, but it's not real Agile, because the teams are still expected to implement requirements without having any input into them or being able to change them. That's not Agile. Agile is about using your team's amazing expertise and having them be involved in deciding what to build and how to build it, because guess what? They have very good knowledge about how to build software effectively, and they might have input which would help you build better features. So again, a lot of software development is premised on the idea of, we'll develop all the requirements up front and then we'll give them to a vendor to build them all. That's highly ineffective. It's really important to have a strong relationship between the people building the team and the people who are responsible for the software and the end users, frankly. And so what all this is saying really is that you should come up with an idea of the outcome you're trying to achieve, and then teams work together with the sponsors, the the agencies to build small increments and then test that with real users, do user research with real users, and then act on that feedback and work in small batches to deliver small increments, validate those, based on that feedback, work out what to do next. That improves both speed and stability, and it impacts your culture. It makes your culture better and more effective. There's also an arrow back from software delivery performance to lean product development, because implementing continuous delivery and these practices that make it possible to deliver faster and more reliably enables you to practice these product development practices, like working in small increments and gathering user feedback and doing user research as you go. So there's kind of a virtuous cycle where being able to deliver faster and more reliably enables kind of lean product development practices and user research, which in turn impacts software delivery performance. So a bit more of a deep dive on culture. What is culture and how do we measure it? We use this model from a sociologist called Ron Westrom. So Ron Westrom was studying safety outcomes in safety critical industries such as aviation, nuclear power, healthcare. So these are very safety critical industries. And what he found is he developed this model which predicted safety outcomes. And it divided organizations up into pathological, bureaucratic, or generative. Pathological organizations, there's low cooperation. Messengers who bring you bad news are shot. Responsibilities are avoided. Bridging between different departments or different parts of the organization is discouraged. When something goes wrong, that leads to scapegoating. It was Jez's fault, let's fire Jez. And novelty is crushed. Whereas kind of the opposite is true in generative organizations. I kind of like to call generative mission-oriented, where people are focused on the mission rather than, or not to say that you shouldn't follow the rules. You should follow the rules, but where following the rules interferes with your ability to deliver your mission, then we'll stop and think about, well, how can we change the rules to better enable us to achieve the mission, which is absolutely something that we have done in 18F and done successfully, and in other agencies as well. There's lots of procedures and processes which are not mandated by OMB, which are agency internal processes, and if those are getting in the way of your ability to deliver your mission, you can and should absolutely go and talk about how you can do process improvement work to improve those processes to better achieve your mission goals as an agency or organization. So, just these 6 axes. Is high cooperation, is cooperation something that happens a lot, or is there low cooperation? Do we shoot people who bring us bad news? Do we train people to bring us bad news so that we can act on it rapidly before things become catastrophically bad, so that we can course correct and fix the problem? Are responsibilities avoided because that if something goes wrong, it's going to be your fault, you're going to be fired? Or do we share risks because we know that we succeed or fail as a team? Do we encourage bridging between different parts of the organization, or is that discouraged? And then 2 things that are really 2 sides of the same coin. How do we deal with failure? In complex systems, like the organizations we work in, failure is inevitable. So when failure happens, does that lead to, well, it was Jez's fault, let's fire Jez? Or do we say, well, listen, when we fire Jez and hire someone else, could the same thing happen to that new person? Well, yes, unless we've changed the way the system works, probably the next person in Jez's role is going to have exactly the same problem. So what did we achieve by firing Jez? Rather, what we should be looking at is how can we get people better information that they can act on more effectively, and how can we build systems such that when something goes wrong, that can be caught and fixed quickly, rather than leading to catastrophic cascading failures. And then finally, how do we deal with novelty? Is novelty implemented? Does it lead to problems like scope creep, or is novelty crushed? And those are 2 sides of the same coin, because if I know that failure will be punished, I'm not going to do anything new. I'm not going to innovate, because I know that the risks, if the innovation fails, which it probably will, because by definition we're doing something that hasn't been done before, that will lead to finger pointing and very negative individual consequences. And this is kind of true in both the public sector and the private sector. The risks are a bit different. What people are afraid of is a bit different. You know, in the private sector, you're afraid of being fired. In the public sector, everyone throws around this thing about, you know, you don't want to end up on the front page of the Washington Post. But it's fundamentally the same thing at play here, which is, you know, you want people to innovate, but there's this thing, well, if this has never been done before anywhere, do I really want to do this? And so what we want to try and do is make it so that it's safe to fail by building systems where we can detect failure before it becomes catastrophic, and where when we find things going wrong, we can fix them quickly and rapidly. And again, a lot of this stuff I'm talking about today is about building technical systems and organizational systems that enable that, where we can detect and respond very rapidly based on what we learn as we're building the systems and products and services that we're building, rather than, you know, spending 2 years on something and then finding out that it's a disaster at the end. We actually did some research here at Google on how to build high-performing teams. And, you know, everyone really thought it would be hire a bunch of Stanford graduates, fire all the managers, and just let people get on with building Node apps. What we found actually was the most important factor was psychological safety, that team members felt safe to take risks and be vulnerable in front of each other. And then these other 5 things that you can read about on the blog. I'm sure many of you have heard of this research. The interesting thing is that we actually validated that this is a replication of our results from Western. So these things that Western talks about here, that's the same as the first 2 things in Google's survey. I mean, that's what we found when we did the statistical analysis. They're talking about the same thing. So this is kind of a replication of what we found in Google. As I say, dealing with failure is inevitable. If human error, you know, Jez did it, is your conclusion, you haven't learned anything. What you want to find out is why Jez made that mistake. How can we build better systems and get people better information to prevent that happening in future? One way to do that is, and one way to improve that process is by actually doing disaster recovery testing. So disaster recovery testing exercises are something that we do all the time in Google. We do one every year. And we actually have a whole team whose job it is to kind of design these disaster scenarios. Like one year it was aliens invade Silicon Valley. And we do things like, you know, turning off the fiber connection between Mountain View and the rest of the world, powering down data centers and so forth, and making sure that our systems can still operate. And the interesting thing about that is this comment by Kripa Krishnan, who is a director of cloud operations at Google. She says, for DIRT-style events to be successful, an organization first needs to accept system and process failures as a means of learning. We design tests that require engineers from several groups who might not normally work together to interact with each other. That way, should a real large-scale disaster ever strike, these people will already have strong working relationships. So when something goes wrong, you want to be like, okay, I know what to do in this situation. I need to ping this person, and we need to work out what to do about this. And then, you know, okay, we're going to go and do this now, rather than panicking and not knowing what to do. Unfortunately, last year we asked about this. We found, in fact, this year we asked about this. We found that only 40% of respondents perform disaster recovery testing at least annually on production infrastructure. So that's something that is really important to do, so that you can actually know that when something goes wrong, that your processes for dealing with that will work. Having a disaster recovery plan without doing disaster recovery testing is like having backups without practicing restore, which is to say useless. So find ways to practice things going wrong so that when things do go wrong, you know how to deal with it. Other ways to improve culture. So, you know, if you want to improve your culture, we've talked about a number of things already. As I showed earlier on, these lean management and product development practices all impact culture. Continuous delivery, these continuous delivery practices impact culture. Last year, we wanted to look at some other things that might impact culture. We found that autonomy is really important. Building small teams that have autonomy in terms of how they achieve their goals is important. That creates higher levels of trust. Creating high levels of trust creates voice, which means people feel comfortable speaking up about things. Where you have teams where there's high levels of trust and people are comfortable speaking up, those things positively impact culture. We also found last year, I talked about heavyweight change process and the problems with that. Functional outsourcing reduces performance. That's when you have a separate team. You outsource, for example, testing, or you outsource operations. And there's a really good deep dive on that in last year's State of DevOps report, where we actually do economic analysis on that. And what's going on here is functional outsourcing makes it expensive to do handoffs. So you hand off some work from development to testing, testing to operations. That handoff is expensive where you have functionally siloed teams. And so when it's expensive, it drives up lead times. It takes longer to get anything done. It drives up batch sizes. So you end up doing these big chunky releases because it's so painful to get anything done. And because you're increasing lead time, you can actually look at the cost of delay, the additional cost of delay of working in this paradigm, where it just takes much longer to get anything done. If there's a cost associated with not having features delivered, you can measure that against the cost savings from functional outsourcing, and you can actually use an economic model to look at whether it's economically positive to do functional outsourcing based on the fact it's going to take you much longer to get anything done. Well, if there's an economic benefit to getting things done more quickly, that may well outweigh the economic benefit of outsourcing. And that's something that people should actually model economically. So functional outsourcing makes things worse. Don't do that. There's nothing wrong with using vendors to do things. That's absolutely fine. But those vendors should have complete end-to-end control over their ability to design and deliver digital services. You shouldn't outsource, testing to one vendor and development to another vendor and operations to a third vendor. That's a bad idea. And fundamentally, what you want to do is create teams. I love this phrase from Reed Hastings of Netflix: highly aligned, loosely coupled. You want your teams to be very aligned in terms of their strategy and goals, which is a key piece of leadership and management. There's kind of two main roles for management here. One is creating alignment so that teams are clear on what their goals are in measurable terms, what outcomes they're trying to work on. And then B, capability development, providing the teams with the resources and skills and time they need to develop the necessary skills in pursuit of those objectives, like paying for training and giving people time to experiment with new technologies and so forth. And then loose coupling, make it so that teams don't need high bandwidth discussions in order to get anything done. So you want to make teams cross-functional. You want to make your architecture so that you can deliver independent pieces without, high degrees of coupling, which goes back to those architectural things that I talked about here, these architectural outcomes. Those actually enable teams to become more autonomous and move faster. So I just want to end the research piece of this by looking at how you adopt these practices. And what we find, we looked at this last year. What we find is, this is a call, this is a presentation that was enabled by a community of practice. And we find that elite performers are strong users of communities of practice. So communities of practice are a great way to spread knowledge and adopt these capabilities. You can see also that proof of concepts can be a good way to try these things out, unless they stall and don't get used. Centers of excellence, not so good. They tend to be used by low performers more than high or elite performers. And again, but big bang rollouts of new practices tend to not do so well. They tend to be used by low performers. And in general, grassroots or bottoms up adoption tends to be used by elite performers. The important thing here is that has to be enabled by leadership. Leadership has to provide the context that enables bottoms-up grassroots communities of practice adoption of these capabilities. So yes, the adoption is happening in a grassroots bottoms-up way, that's only possible where leadership actually enables and encourages that to happen. So just a few notes on, something that I did in government, which I thought was a great exemplar of this. I worked on a team, originally started off by Diego Lapidas, working on cloud.gov. Cloud.gov was fundamentally about making it possible to deliver government services more quickly. We did some research and found out it took like 9 months to build and deliver government information systems just to go through the NIST risk management framework. And the idea was, well, if we can build a bunch of these controls into the platform, then when you're developing software that runs on that platform, you don't need to care about as many of those controls. And so you can get through the risk management framework more quickly and deliver stable systems, reliable systems more quickly. And so cloud.gov delivered on that promise. By the time that got FedRAMP authorization in 2017, cloud.gov actually handles 269 of the 325 security controls you need to implement if you're a moderate impact government information system, which meant that if you're delivering software running on cloud.gov, you only need to care about between 15 and 56 of those controls listed in NIST 800-53. And I think the important thing to point out is this was built using the principles I've discussed in this presentation. They use continuous delivery. If you want to make a change to the configuration of cloud.gov, you push a change into GitHub and it's delivered using CI into production in an entirely automated push button way. So all this to say, it's absolutely possible to deploy these practices and capabilities inside the federal government. Cloud.gov, I think is interesting, not just because we built cloud.gov, but because we showed that you could do that in the government. One of the things that we all fought for, I think unsuccessfully, was to get the system security plan for cloud.gov published publicly so that other people could see what we did. If you're working in an agency and you're like, well, how do I actually make sure I can meet the requirements of NIST SP 800-53, go and request a copy of the system security plan for cloud.gov from the FedRAMP team and take a look through it. I think in a way, the SSP that we put together is probably the most interesting artifact that was created as a result of cloud.gov, because it shows how you meet those control objectives in the NIST risk management framework using the capabilities and practices that I've talked about today. So that's it. I just want to end with this quote from Rear Admiral Grace Hopper that I love. She says, if it's a good idea, go ahead and do it. It's much easier to apologize than it is to get permission. If you want to find out more about all this stuff, you can go to cloud.google.com/DevOps. You can find the last 6 years of the State of DevOps reports and a whole bunch of information on these capabilities that I talked about and how to implement them. And with that, I'm going to turn it over for questions.
Jez, thanks so much. This is Peter Burkholder. I'm in Tuscaloosa, Alabama. I was able to join for 5-6 of this and really appreciate you coming and sharing from your experience. We have a few questions that have been being dropped into the chat, but I'll just start with one of my own. When it comes to communities of practice, we see that those are used by elite performers. What are some elements of effective communities of practice?
So I am not an expert on communities of practice. There's actually some great work done in the UK government by Emily Webber on communities of practice. So I would go and look at Emily Webber's work. She knows much more about it than I do. But what I think, like the one thing I would say is, it's really okay. 2 things. Number one, you can't just apply the things I've talked about by following a recipe. You will have to work out for yourself how to implement these things, and it's going to be different everywhere. And that for me is why communities of practice are so important, because that's your support network. Well, I want to implement, for example, test automation. How do I do that? Well, that's where your community of practice can help, because it can be like, well, here's how we did it here, here's what works, here's what didn't work. And you can be like, okay, well, what should be my first step? And then they can help you out. And then you can be like, well, we did this experiment, this is what happens. And again, a community of practice is a great way to share that and get feedback. So it's kind of your support network for experimenting. I think that's a good way to think about it. And it's really important to try and get your management and leadership to invest in that, because communities of practice are one of the things that make it safe to really A, experiment, and B, get the flow of information throughout the organization. Westrom's model is one of the things it's talking about is how organizations process information, how information flows through the organizations. And communities of practice are a great way to enable that. They enable bridging, they enable cooperation, and you can think of it as a way of enabling or making it lower risk for teams to experiment, and that's why I think they're so important.
Right, and another question that came in from is, do you have some additional examples of organizations with generative cultures and how it has helped them perform? I think that's asked for like how organizations have been able to change their culture over time.
Yeah, great question. So one thing I will say is that you will, certainly in big organizations, you're not going to find a big organization that is generative throughout. That's not the case. What you find is you go into organizations and you find some teams that are generative and some teams that are bureaucratic and some teams that are pathological. So it's on a team basis, not an organizational basis. And that's true everywhere. You know, I work in Google. You know, I think I can safely say there's some teams that are pathological and there's some teams that are generative. And that's true in the federal government. I'm sure all of you on this team, on the call, have worked in teams that are pathological, teams that are bureaucratic, and teams that are generative. So it's not really on an organization basis, it's on a team basis. And I honestly don't believe that there's any difference between the private sector and the public sector here. Any big organization, there's going to be pathological teams, there's going to be bureaucratic teams, there's going to be generative teams. And a lot of it depends upon your management and your leadership. I think that's probably the biggest factor which is going to impact that, is the extent to which your management and leadership is going to be supportive of your teams experimenting with implementing the capabilities I've talked about on this call, the extent to which they're going to give you air cover, the extent to which they're going to make sure you have the resources and time to experiment with these things and to do process improvement in general. That I think is the important thing. But you find them everywhere.
Yeah, I've certainly seen that play out multiple places in my career too. Let's see, Logan Powell was wondering if there's more tactical advice for the folks at the operational level for getting leadership buy-in and for advice therein. In other words, examples of how groups did such and such in order to get concrete buy-in from their leadership.
Yeah, I think there's three things. Number one, there's data. So we have a 6-year research program. We've got a ton of data. Everything I've talked about today is evidence-based. So, you can go to this URL. There's 6 years of State of DevOps reports. Those State of DevOps reports are designed in such a way that if there's something you're interested in, there's a couple of pages you can just print out and kind of like casually leave on your boss's desk. So any of the topics I've talked about, you can go and find the appropriate section in the State of DevOps report for the year we looked at that thing. And there'll be a couple of pages which kind of talk about that thing in nice, simple terms with some nice graphs. And you can print those off and give those to people. That's the way we designed those reports. So, hopefully people are swayed by evidence. That's always nice. The other thing that you can look at is case studies. And again, communities of practice are great here, because one of the great things that communities of practice can do is give you case studies. Well, we tried this and it worked over here. And that I know is very important, because you want to be able to say that, we're not the first people who've done this. It was done over here and it worked here. The third thing I would say is, to an extent, this, one of the great things that effective managers can do is provide air cover for teams to go and experiment with things in a way that's low risk. I mean, you don't want to go and often experiment for something with 2 years and then have it go catastrophically wrong. You want to find ways to experiment with something over the course of days or weeks and try it out. And then if it works, what you really want to do is get other people interested in talking about it, because it's much more powerful if other people talk about the cool thing you did than if you talk about it. And again, that's somewhere where communities of practice can really help. That's not necessarily sustainable, because if the manager gets fired or goes off and does something else, then you might get another manager who's like, this is, what are you doing? We're going to stop doing this. So you can't implement sustainable change that way, but you can experiment and then use the successes as a way to drive broader adoption of those practices. So those are my 3 things.
So, and then we had 2 questions that kind of overlapped. Jeremy Ziller was wondering, do you have a scorecard or series of questions that help measure the maturity of DevOps teams on their practices? And Morgan Travis was wondering if there's a diagnostic that can be used as a starting point to analyze how far along the journey you are from low performing to elite. And I know you have opinions on that. So I think we'll take one more question after this then, and then call it a wrap.
Yeah, so all this data is based on surveys. Obviously, the diagnostic is the survey questions. Unfortunately, those are Google confidential. I cannot reveal the questions. Many of the questions are actually in the State of DevOps reports. And if you go to cloud.google.com/DevOps and you scroll down, there's a page for each of the capabilities I talked about. And on each of those pages at the bottom, there is a piece about how do you measure this and how do you implement it. So if you want more information on how do you measure this, how do you implement it, go to cloud.google.com/DevOps, scroll down, and at the bottom you'll see there's, or just above the bottom, you'll see there's like a link for each of these capabilities which talks about how to measure it, how to implement it, and so forth. We're in the process of building a diagnostic tool. It's not ready yet. In the meantime, go and check out those resources.
Great.
It's all free.
Terrific. And of course, there's the chapters in Accelerate as well that cover this too.
Yep.
And then lastly, from Rob Wilkinson, have you seen teams incorporate DevOps practices when they work in environments that, due to security concerns, have audits and deployment restrictions that can't necessarily be automated?
Yes, absolutely. And it's even more important to do these things in situations like that. All this stuff is best implemented in an incremental and iterative way. I'm not suggesting that you go off tomorrow and try and deploy all 28 plus of these capabilities. What you're going to have to do is work out what your constraint is right now and try and improve that one thing. Find 1 or 2 things that are your constraint on your ability to get better. And actually, that again, on cloud.google.com/DevOps, there's a whole page on how to implement this stuff. But the TLDR of that is, you've got these 4 metrics, and here, these are the actual questions we ask on the survey. So if you want to know that, it's here. Set targets for those things. Right now, our deployment frequency is once a month. We want it to be, once every 2 weeks. What's your constraint? Well, it's this thing. How can we get better at that thing? Well, it might be some automation. It might be process improvement. One of the coolest things that we did at 18F, I thought, in this area, was just go and talk to the CISO. And the CISO at GSA at the time was pretty awesome. And he had all these ideas about reducing the burden of the NIST risk management framework and a lightweight process for doing that. And, and the CISO was pretty on board, and we found ways to do process improvement. The thing I would say is this, there's a phrase in that question that was problematic, which is like, due to security restrictions, we have to implement this process. I don't think that's ever true. The thing that you care about is the control objective. And if the process is not the best way to achieve the control objective, if you have a better way, you should go and have a conversation about that based on the control objective you're trying to talk about. Process improvement is essential in government as it is anywhere else. And go and find those people and talk to them about, well, this process is actually hindering our ability to build security into our software and deliver with speed and reliability. We probably have some shared objectives around here. How can we work together to do this? And take an incremental, iterative approach to process improvement and implementation, the same way as you do with product development, but go and have those conversations.
Kaizen, absolutely, Jez. Continuous improvement. Jez,
Yes.
thank you so much today for the terrific presentation and the little bit of Q&A we were able to get to. So thank you so much for your time and all these terrific thoughts. Just to wrap it up, reminding everybody, we will be posting the video later. And feel free to continue the conversation on the listservs and on digital.gov. You can go out there to sign up for the listserv. Also, just a reminder, there are other upcoming events. We've got another holiday special planned for early December. Nicholas Shalon with the U.S. Air Force will be presenting. He's the Chief Software Officer there. So we're looking forward to that on the 3rd of December. And we, to some of Jez's terrific points, we're going to have a panel in late January. We're going to change the event a little bit. And the panel is going to have some folks from USGS, OPM, and Patent Trade Office, et cetera, really talking about how are you enabling learning within your organization, communities of practice at the agency or department level. And then, as always, we've got monthly events planned out through July. I want to thank everybody for offering up to present and share within this community of practice. If you want to present, just email me, brian.fox@gsa.gov, and we'll get you on there, but it might be August when you're sharing. So thank you, everybody. There's a lot of energy building around this, so sure, appreciate it. Jez, anything else, sir?
Just thank you so much for inviting me on. It's a pleasure. Thank you all very much for your service, and have a fabulous holiday season.
Absolutely. Jez, thanks again. And thank you all for joining. Sure appreciate it.